This question is from K 2021 Mechanical Engineering Paper Set 1, question number 53. A short shoe drum of radius 260 mm brake is shown in the figure. A force of 1 kN is applied to the lever. The coefficient of friction is 0.4. The magnitude of torque applied by the brake is dash Newton meter. Let's find out. We need to find out the torque. Torque will be given as the tangential force, which is nothing but the friction force between the brake and the shoe, into the radius of the brake drum, capital R. So we know the radius of the drum already as 60 mm. The only thing we don't know is the friction force F. So we need to find out that. Let's first draw the free body diagram of the brake. So here's the lever with the 1 kN force on the right side as given. And here's the shoe. We will just mark the friction force and the normal reaction. We'll not draw the brake drum here. So this distance from the center of the shoe to the both sides of lever is 500 mm each side. This distance we can find out because this total from here to the center is been given as 310 millimeters and radius of the brake drum is given as 260 mm. So this distance can be found out by subtracting 310 and 260, which is nothing but 50 millimeters. Now normal reaction will act like this between the shoe and the drum, and frictional force will act this way, tangential to the surfaces. This is F, this is N. F can also be written as nu into N. So we'll write down the equilibrium equation for this system and try to find out F from there. Pivot point is here. So we can take summation of moment about the pivot point is equal to 0. That is nothing but 1 kilonewton into this distance creates a clockwise moment. Will take clockwise positive. So we have 1 kilonewton, which is nothing but 1000 Newton into the distance is 1000 millimeter. We can take it as 1 meter. This is positive. Then friction force F creates an anti-clockwise moment, which is at 50 millimeter vertical distance. So we can take it as minus F into 50 millimeter. We can write this as 50 by 1000 meter. And we also have moment created by N, which will be also the anti-clockwise moment. So minus N into distance is 500 millimeter. So we have 500 divided by 1000 is equal to 0. So simplifying this, we have 1000 minus 5 by 100 is nothing but 1 by 20. So F by 20 minus 500 by 1000 is 1 by 2. So N by 2 is equal to 0. F can be put as nu N, and we'll first find N, from where we can find out F using nu N itself. So we have 1000 minus nu into N by 20 minus N by 2. Rearranging this, we have coefficient of friction is given as 0.4. So we have 0.4 by 20 into N plus N by 2 is equal to 1000. Taking N common, 0.4 by 20 is nothing but 4 by 200, which is 1 by 50. So 1 by 50 plus 1 by 2 is in the bracket is equal to 1000. By rearranging, we have N value turns out to be 1923.08 Newton. Now putting it here, we have F will be equal to 0.4 into 1923.08. So F turns out to be 769.23 Newton. Let's go back and fill in this answer. We have the friction force. Now we need to find out the torque. So we'll find the final answer here for torque. We have 769.23 Newton is the friction force into the radius is given to be 260 millimeter. Converting this to meter, we have 260 by 1000. So this gives us the torque value as approximately equal to 200 Newton meter. Let's go back and fill in this answer. So magnitude of torque applied by the brake is 200 Newton meter. To learn more about brake systems, you can refer to the NPTEL video Brake System Part 1. It's from the course Fundamentals of Automotive System. This course is taught by Professor C.S. Shankar Ram. He is from Department of Engineering Design of IIT Madras. I hope this solution helps you clear your doubt. Thank you.